What if I told you that predicting tomorrow's weather means running more calculations than millions of humans could do in a lifetime? For most of us, a weather forecast is just a quick glance at an app or the TV to see if you need a brolly before heading out the door. But behind every weather symbol or warning lies one of the most powerful computers on the planet. A machine so advanced it helps us understand not just if tomorrow will be wet or dry, but the future of our climate. In this video, we're going to peel back the curtain on how weather forecasting has evolved, from hand-drawn charts and mathematical equations, to computers that take up the size of a room, to the cutting-edge cloud-based system that's changed the way we forecast forever. It's a story of science, storms, and supercomputers, and how technology is giving us a clearer window into the skies above. Before the age of supercomputers, weather forecasting was a slower and more hands-on process. Forecasters relied on barometers, wind vanes, and cloud formations to read the sky, combining careful observation with experience to anticipate what might come next. By the early 20th century, meteorologists had begun using complex equations based on fluid dynamics and thermodynamics, the science behind how the atmosphere behaves. But there was a major challenge. Solving this vast number of equations by hand took an extraordinary amount of time. One of the pioneers of numerical forecasting was Lewis Fry Richardson, an English physicist and mathematician. During the First World War, he attempted to calculate a 6-hour weather forecast using nothing but pen, paper, and brainpower. It took him 6 weeks. Imagine waiting that long just to decide whether to pack an umbrella. In 1922, Richardson published Weather Prediction by Numerical Process, where he imagined a vast forecast factory filled with 64,000 human computers, each working on a tiny piece of the globe. It was a vision of collaborative calculation on an industrial scale. And while it may have sounded fantastical at the time, Richardson's idea wasn't far off. Today's supercomputers do exactly what he imagined, dividing the world into grids and solving them simultaneously. The difference is we've replaced thousands of people with processors. This shift from paper to processor marked a turning point in forecasting. It opened the door to a new kind of machine, one that could take Richardson's vision and turn it into reality. And that machine would change everything. Attempts to use early supercomputers in meteorology began in the 1950s, and the following decades saw increasingly powerful machines being developed specifically for numerical weather prediction. By the 1980s and 1990s, these machines became the analytical engines behind every forecast, transforming data from thousands of weather stations, satellites, aircraft, and radar into predictions for the skies above. In the early 2000s, the Met Office supercomputer was a powerhouse. It could perform over 14 quadrillion calculations every second. That's more than 2 million calculations every second for every person on Earth. It held memory for hundreds of trillions of data points and had enough storage to save over 100 years' worth of HD movies. Inside, compute cores worked in parallel, solving the same equations that Lewis Fry Richardson had imagined nearly a century earlier, but now at lightning speed. The old supercomputer was like a room-sized brain. It was immensely powerful, but physically confined. It laid the foundation for a new generation of forecasting technology, proving that with enough computational strength, we could begin to see the weather before it happens. But the story doesn't end there. In fact, it's only just the beginning. For decades, the Met Office relied upon on-site supercomputers to power its forecasts. These were vast machines physically housed and maintained in Exeter. But in a major technological shift, the Met Office has now moved its core forecasting operations to a cloud-based supercomputer hosted by Microsoft Azure. This one lives in a network of high-performance data centres, making the UK the first national meteorological service to fully embrace cloud computing for forecasting. Unlike the old systems, the cloud offers scalable and on-demand computing power. This allows the Met Office to process over 215 billion weather observations every day and run more detailed, longer-range models than ever before. Millions of lines of code in the momentum model, the unified framework at the heart of forecasting, are executed in parallel to deliver faster and more precise predictions. But the shift is not just about speed. It brings flexibility, future-proofing, and opens new possibilities for climate science. This system now supports 14-day forecasts with the kind of accuracy that was previously only possible for 7 to 9 days. It also enables advanced climate simulations to help us better understand future risks such as floods, heat waves, and changing storm patterns. So how does all this data become the forecast you see on your screen? Well, it starts with knowing exactly what the weather is doing right now. Every day, billions of observations from satellites, weather balloons, aircraft, radar, and over 300 land-based stations across the UK are collected, quality-checked, and fed into the system. Temperature, air pressure, and wind speed are all recorded. We also need a three-dimensional picture of the atmosphere. Balloons measure high-altitude conditions, satellites capture imagery from space, ocean sensors track temperatures and waves, and radar maps rainfall. Where there are gaps in coverage, such as over oceans, remote areas, or high altitudes, data assimilation fills in the blanks by combining observations with expected conditions. Next, the cloud supercomputer takes over. The momentum model runs millions of lines of code across thousands of processing units, solving complex equations to transform raw data into detailed forecasts. Finally, meteorologists refine the output. Small adjustments such as a patch of cloud or a single degree of temperature make the forecast more accurate and relevant. The cloud system lets meteorologists focus on both the data and the context, turning millions of calculations into clear, meaningful forecasts, giving people the insight they need to plan their day, their week, or to understand how climate change could shape the weather in the future.